Welcome to this explainer on Cisco DNA Center. If you've ever burned hours, or honestly days, punching the exact same command lines into endless rows of hardware, you already know exactly how tedious network management used to be. But today, we're diving into a complete paradigm shift. We're moving away from rigid manual processes and stepping into an intelligent, automated, and AI-driven blueprint. Just picture the absolute nightmare of managing a massive scale-out. Let's say you have 500 branch offices, 2,000 switches, 800 routers, and maybe 5,000 wireless access points. What happens when a new employee joins or a global security policy changes? In the old days, you'd be configuring VLANs, assigning IP addresses, and updating switches one by one. It would take weeks, and a single command line interface or CLI error could literally bring the entire network to a grinding halt. Today's explainer maps out exactly how to escape that manual nightmare. We're going to hit 4 key areas. 1. The traditional network problem. 2. SDA and policy definitions. 3. Fabric automation. And finally, 4. AI-driven assurance. Let's get right into it. Starting with Section 1, the traditional network problem, slow deployments and cascading errors. So, looking at the old way, it completely relies on slow device-by-device management. Every single router, switch, and firewall needs individual TLC. If an office opens, deployment drags on, and when things inevitably break, you're stuck doing purely reactive troubleshooting. You might search for hours just to find the root cause. But Cisco Digital Network Architecture, or DNA, flips the script. It shifts everything to a fast, centralized, and automated model using proactive AI. You get this intelligent brain that looks at the network end to end. This is honestly a brilliant analogy for the paradigm shift. Think about it. Instead of you manually driving the CLI for every single network device, which is basically like trying to steer 1,000 cars at once, a centralized brain manages the traffic for you. It knows the routes, it sees the bottlenecks, and it optimizes the flow of data across the entire enterprise. You just set the destination. Moving on to Section 2, SDA and policy definitions, shifting from manual VLANs to intent-based rules. Software-defined access, or SDA, is the absolute game changer here. In a legacy setup, keeping different departments secure meant manually configuring VLANs on every single switch across your campus. Super tedious and incredibly prone to human error. Well, SDA completely axes that need. Instead, you use intelligent, centralized policy definitions. You tell the network what you want to happen, and the architecture makes it happen across this highly intelligent fabric. So the crucial point here is that instead of tedious, repetitive commands, administrators just define simple, intent-based rules. You literally just say, HR users only access HR resources, or finance connects to finance servers. If a guest logs in, boom, restrict them to the internet only. You define these rules just once in the DNA Center dashboard, and the network automatically enforces it everywhere, no matter where that user actually sits in the building. It's segmentation made incredibly simple. That brings us to Section 3, Fabric automation, erasing the manual CLI workload entirely. Fabric automation is arguably Cisco DNA's biggest strength. Pushing a new config used to mean repeating the exact same task 100 times over. Now, automation handles the heavy lifting. You build a single configuration template within DNA Center. Once it's solid, you hit a button, and DNA Center pushes that configuration automatically across the entire enterprise fabric, instantly. The time you save here is absolutely massive. Let's look at how this plays out in the real world with plug-and-play automation. Say you're opening a new branch office. Step 1, you physically connect a brand new switch to the network. Step 2, that switch automatically calls home to DNA Center. Step 3, it immediately downloads its configuration template. It's fully operational with zero manual CLI work. You don't even need a senior network engineer on site. Someone just literally needs to plug it into the wall. But Fabric automation does way more than just the initial setup. We're talking about automating the complex day-to-day operations too. It handles VLAN creation, interface configs, managing quality of service, deploying access control lists, and even wide-scale software upgrades. By letting the Fabric manage all these capabilities, you dramatically reduce deployment times and basically eliminate the chance of human error sneaking in. Now, you might be wondering, how does the Fabric actually know who's who? Enter Cisco's Identity Services Engine, or ISE. When you pair this with DNA Center, any connecting device, whether it's an employee's laptop, an IoT security camera, or a guest smartphone, gets automatically authenticated. ISE identifies what the device is and instantly drops it into the correct policy group across the fabric. So that IoT camera gets locked down to the camera VLAN right away. No manual intervention required. Finally, let's hit Section 4, AI-driven assurance, looking at real-world scale and proactive monitoring. To really grasp the scale of this, picture a massive university campus. You've got 20,000 students, 2,000 access points, 500 switches, and hundreds of classrooms. As these students roam the campus, walking from their dorms to lecture halls, the automated fabric ensures they stay seamlessly connected without dropping a session. Managing that kind of mobility manually, literally impossible. Meanwhile, running in the background, Cisco DNA is relentlessly analyzing network telemetry. It's pulling in millions of data points from every single device on the fabric. It breaks down complex data on things like high latency, packet loss, wireless interference, and roaming issues. You get a completely holistic view of the overall network health, client health, and application health, all sitting right there in a single dashboard. And here is where it gets really fascinating. The AI doesn't just passively watch your dashboard, it actively works for you. If it detects a hardware failure, an overloaded switch, or an app slowdown, it doesn't just blink a red light. The AI network assurance engine actually analyzes the root cause and recommends corrective actions. In a lot of cases, it helps flag and fix the issue before that university student even notices their Wi-Fi was glitching. So when you wrap all this up, bringing intuitive policy definitions, zero-touch fabric automation, and proactive AI together into one blueprint, the benefits are undeniable. Centralized management, massively faster deployments, and AI-driven troubleshooting all translate to significantly lower operational costs and a way better user experience. You're basically building a highly scalable enterprise network that practically manages itself. To wrap up this explainer, I'll leave you with this thought to chew on. Knowing the immense capabilities of software-defined access and fabric automation, how much time, money, and sheer frustration could your own organization save by finally retiring the manual CLI? Letting an intelligent, centralized brain take the wheel is a massive leap forward, and it's definitely a question every modern IT department needs to ask themselves today.